So factor it. What does it factor into, Olivia?
It factors into x minus 2 and
X minus 1. Good. So it crosses the x-axis at
x
1 and
2.
is it facing up or down? Up. So we have x is 1 and 2, and it's facing up. So it's going to look like this, right? There it is. And y equals 0. What is y equals 0 also known as, Claire? What's that called?
Straight line on the y-axis.
The x-axis. It's not the y-axis, it's the x-axis. So we have our region, it's right there. And what are we rotating it around? This one's nice because it's pretty easy to draw the other piece of it, the mirror image, like this. What do you draw after you do that? Does it say which method you have to use? You can use either one. Which one do you want to use? Shells. Shells will be easier on this one. So you draw your line right there, and you end up with a shell that looks like that. There it is. Are we integrating with respect to x or y?
X.
With respect to x. Good. So it's going to be 2 pi, the radius times the height. And we're going from what to what? What are our limits here? We already figured it out. 1 to 2. That was the first thing we figured out. Nice, 1 to 2. In this case, the radius is just going to be what?
X.
It's just x because it's going around the y-axis. And the height in this case is the distance from here to there. Well, that's 0, and then you have the lower function. So what's the h going to be? It's going to be 0 minus what? X squared minus 3x plus 2. So our integral is going to be 2 pi 1 to 2 of x times negative x squared plus 3x minus 2 dx. There it is. What'd you get for an answer, Mariah?
I got
Pi over 2. That sounds right. That sounds right. 5 is equal to x plus 4 over x. To solve this, what do we need to do? Times it by x. So 5x equals x squared plus 4. So 0 equals x squared minus 5x plus 4. So 0 is equal to x minus 4 times x minus 1. So x is equal to 4 or 1. So let's say that I'm going to use a different scale here. Here's 4 and here's 1. To get the other points, you could literally just pick values. Can you plug in 0 into this? What's going to be at x equals 0? Vertical asymptote, right? So you know it's going to look like this, and it will end up like this if you do it out. There it is. So what region are we looking at? There it is. And what are we rotating it around? This is slightly different. We're rotating it around x equals negative 1. So we're rotating it around this right here. X equals negative 1. So can you draw the mirror image pretty nicely? Yeah, that's pretty good. So we have to go make sure we go 1 from, so where's it going to be? It's going to be right here and right 1, 2, 3, 4. Wait, 1 and 4. Let's just say that's 4. Great. So there's our mirror image, right? What do we draw? We draw one of our shells. Shells is definitely going to be the easier one here. And we have this part and this part, so we end up with, there it is. Are we integrating with respect to x or y? Absolutely. And we're going from what to what? 1 to 4. We're going from 1 to 4, and it's 2 pi RH dx. In this case, the radius is going to be what? You have to be very careful about this, because are we rotating it around an axis? No, it's going to be x plus 1. The radius is this distance from here to here, right? You have to add 1 to that. You're subtracting negative 1 is the algebraic way to think about it. If that was x equals 1, we'd be subtracting 1, right? But we're not. So we do this, and we end up with, what's the height going to be? 5 minus x plus 4 over x. Exactly, good. So what do you end up with? You end up with 2 pi integral from 1 to 4 of x plus 1 times 5 minus x plus 4 over x. And what goes on the outside? What am I missing? Dx. Can you do this one by hand? Yeah, you absolutely can do this one by hand. So if this was a non-calculator one, you absolutely could. Does anybody have an answer for this one? Did anybody get an exact answer? Yeah, what'd you get? It looked like you were about to say something. No? We'll do this one. If you rotate a circle around its axis, what do you end up with? A sphere. Congratulations. It's a sphere.
It's spelled
X-axis, so 2.
Oh, okay.
21's easy, but
I'm sorry. This is not the one I thought it was. My mistake. I'm kind of a jerk. I'm sorry. You rotate this. You're totally correct. You get a donut, but there's no real hole in the middle, is there? Right? Do you see what's going on here? Okay. Imagine it's spinning like this, right? It's just a donut with no. You squeeze it in until there's no hole, right? So you just take this and spin it. Okay, yeah. If you rotated this around the y-axis, you get a sphere. And do you have a formula for the area of a sphere? 4/3 pi r cubed. You can use that. That's fine. And determining that is actually pretty easy. That's fine. This is a little different, though, right? Now, do you want to use washers or cylindrical shells? How do you if it's not readily apparent which you should use? If it's not readily apparent which you should use, draw them. So which one do you want me to draw? Pick one. Which one do you want me to draw? Which one? Shells. So let's draw a shell. So a shell is going to look like this. So there's one shell. So there are the two circles. What's it going to look like if I did a washer? There's the washer, half of it anyway. Which one looks like it's going to be easier to deal with? Shells is definitely easier to deal with here. Not so much, but I prefer it in this case. Okay, so let's do it with shells. Are we going to integrate with respect to x or y? With y, yep. And we're going from the bottom to the top, so we're going from 0 to what? 0 to 2, exactly. And it's 2 pi RH, and it's dx or dy? dy. So we need r and h in terms of y. It's dy in terms of y. We're isolating x because we need everything in terms of y. So which one do you want to do for? Oh, the radius is easy. What's the radius going to be? No, the radius of the circle is 1. But what the radius is this distance right here, kids. This is the radius right here. From here to here. What's that called? That is y. Yeah. Someone say y. I thought you said 1. I'm sorry. It's YH. Absolutely. Y. So we're good. We're okay. But what do we need now? We need the height. So let me just scale this in. So that the y, there it is. Everybody sees it, and you can't see that because it's too dark. Sorry about that. So you end up with, what is it, 0 to 2? I'll try to do the color around it. Let's see what I can do here with this. Okay, is that good? Yeah. That's not bad. So now we need h. Where's h going to be? I'll use a lighter highlighting here. H is this distance right here. That's the distance we need now, but we need it entirely in terms of y. It's a horizontal distance, so that's an x distance. So what do we need to isolate? We need to isolate x. If we isolate x, we end up with x squared is equal to 1 minus y minus 1 squared. So what does x equal? Square root of 1 minus y minus 1 squared, right? Plus or minus. So one of them is the right side and one of them is the left side, because to the right of the y-axis is x is positive. To the left of the y-axis, x is negative. So which one do we want? Well, what can you tell me about a circle? It's symmetric. It's an even function, exactly, right? So we know that this distance right here, the positive distance is right here. But we want the distance all the way across. So what do we do with the positive distance to get the entirety? Multiply it by 2. So in this case, what is h going to be? 2 times the integral of 1 minus, well, not y minus 1 squared. So what is our integral going to be? 2 pi integral from 0 to 2 of y times 2 root 1 minus y minus 1 squared dy. Does this look like something you can do by hand?
no. Yes.
Possibly. I mean, possibly. What method are you going to have to use if it's possible? You're going to have to use substitution. And the thing that makes it seem like it's doable is this. What's the degree of the radicand right here? What's the degree of this? To the second. When you square that, it's a quadratic, right? So the power is what inside here? 2. What's the power on the outside? Is that a good sign for substitution? Yeah. If it's 1 less, you hope it cancels. You need it to cancel, right? So if we were going to use substitution on this, what do we need to do first? We have to multiply it out first. So let's multiply it out and see